Yes, I am pursuing PhD in ISC Bangalore. Currently, I am now in fifth year. I will soon write my thesis.
Sir,
My domain is basically in fracture. I see the effect of electric current pulses on the fracture behavior of material, mostly aerospace alloys, aluminum alloys or steel.
sir, I heard that in ISC Bangalore we can complete PhD in 3 years. Is it right, sir?
No, actually, it depends. Like in some labs, like there will be different professors, right? So every lab has certain culture. So in few labs, you can complete your PhD in, let's say, 4 years. Minimum is 4 years, not 3 years. 4 years minimum is required, and in some lab, it requires like 7 to 8 years also, because the professor is not satisfied with the work. So it depends. It's not like every person will leave ISC in, let's say, in 3 4 years. It's not like that. So you have to ensure that you are choosing right professor if you are coming to ISC for PhD, depending on your topic of interest, as well as you need to see if you are going under correct professor or not.
Okay, sir. I got it.
You want to pursue PhD further?
Yes, sir.
Okay. Then ISC is really nice place to pursue PhD, as most of the students here are MTech and PhD only. So if you can try to get MTech here using GATE score, then you are most welcome here, and then you can go abroad for doing PhD. Otherwise, you can take direct PhD here.
Oh, so which one should we get, sir? Like less than 50?
For MTech, depends on category. For general category, you should be in top 30, 30 or 40. And what happens in direct PhD is like they call like top 20, 200 students from like ranks from top 200, and then they interview those students, and from the basis of that interview they take students for direct PhD. So even if your rank is lower, let's say like in hundreds or so, then you may get a call for interview, and if you crack that interview, then you can directly go for direct PhD here. For MTech, there is no as such no interview. Then you have to directly go to using Gate rank only. They will shortlist you. So for that, you will be required to get at least like 30 40 if you are in general category.
Okay, sir.
Yeah. So I guess we have waited for like 4 minutes. We will wait for 2 minutes, then we will start. Today's questions are purely based on mechanical metallurgy, and all the questions are like numericals. So how, if we know the formula, we can directly get the answer.
Okay, sir. Sure, sir.
Yeah, in 2 minutes we will start. If anyone joins. Okay, I guess I will start. So what I will do is like I will project first question. I will give you 2 minutes to think on that question, and you guys try to solve it. And after that, we will go through the complete solution. So I will present my screen. Is my screen visible to both of you?
Yes, sir.
Yeah, okay. So I will project first question today. This is the 10th session which I am taking. So I will project first question. Just a second. Okay. So this question is from GATE 2010 question paper, which I have chosen. Now I will like most of the questions I will take from 2010 question paper, and mostly it will be on mechanical metallurgy, manufacturing, and so. So this is the first question. You try to attempt this question, then we will go through the solution. I will give you 2 minutes. Do you guys know which formula to use here?
No idea, sir.
No idea. Devendra, you know?
No, sir.
Uh, you may have heard of considerous criteria, right, in mechanical behavior? Considerous criteria. Okay, then we won't waste time. I will directly start with the solution, as both of you are not knowing this. So this is question number 44, GATE Metallurgical Engineering 2010 question paper. If the true stress strain curve of a ductile material is represented by equation sigma equal to 1100 epsilon raised to power 0.2, then the ultimate tensile strength, engineering tensile strength, will be option A is 853 MPa, option B is 753 MPa, option C is 653 MPa, and option D is 553 MPa. So first of all, we have the equation, which is sigma is equal to 1100 epsilon raised to power 0.2. This is basically the Holloman equation, which is given by k epsilon raised to power n. This is Holloman equation. So what considers criteria is basically d sigma by d epsilon should be equal to sigma. This is basically the considers criteria. Okay, so now we will substitute this sigma in this equation in both the sides. So d k epsilon raised to power n by d epsilon is given by k epsilon raised to power n. We have substituted sigma in this equation basically. So now you have to take derivative of this, which will come as n. K will be remaining as it is, epsilon raised to power n minus 1, and this will be as it is. So k got cancelled. So basically this equation boils down into n is equal to epsilon. So this condition is achieved at UTS. So basically when the strain, like true strain of the material, is equal to the strain hardening exponent, then UTS is reached. So here we don't have the value of epsilon. So the epsilon, this is basically k epsilon raised to power n, and n value is 0.2. So from this equation we will get that the value of true strain at UTS is basically 0.2. Let us term this as equation 1. Now coming to this equation, now we know the value of true strain. We can find the value of sigma, which is true stress. sigma will be equal to 1100 0.2 raised to power 0.2. So this will come out to be 797 MPa. Now what we have to find out is basically ultimate tensile strength, which should be engineering stress strain curve, not a true stress. Basically this is true stress UTS in a true stress strain curve. Now we know that true stress, let me denote it as sigma t, is basically sigma into 1 plus E. This is basically the engineering stress related with the true stress. Now we have to find out this. This is unknown and this we know. And basically 1 plus E can be substituted, as you know that the true strain will be given by ln of 1 plus E. Right? This is the standard equation. So let's say this is basically E. So 1 plus E should be E raised to power epsilon T. By this equation we will get that. Now we will substitute the same in this equation. So epsilon true stress of the material will be given by engineering stress into E raised to power epsilon T. Now we know epsilon T, which is 0.2. We know the true stress, which is 797 MPa. Now we will put this in this equation. 797 will be equal to engineering stress into E raised to power 0.2. So the engineering stress, which is basically the UTS, will be given by this. So if you calculate this, E raised to power of 0.2 is basically 1.22. 797 divided by 1.22. So 797 divided by 1.22 will be 653 MPa. Now we have calculated the UTS in engineering stress strain curve, which will be 653 MPa. So the correct answer is option C. I hope this question is clear. If you have any doubt, you can ask me. So first thing is basically you need to remember Holomon equation and you need to remember this considerous criteria. These two are the important equations here. This is first equation and this is second equation. If you know both these things, and basically you can remember also for gate, it is this derivation is like time consuming. It should not be the case when you are solving. This is for your knowledge only. You can keep in mind that at UTS the true strain is equal to the strain hardening exponent. That you always keep in mind, and rest of them are simple basic formulas. So first formula we used was Holomon equation, second was this considerous criteria. If you don't remember this, just remember this as third formula, and fourth formula was basically this, and fifth formula was this. So total 5 formulas we used here. So you can jot down these all 5 formulas in separate sheet, so that if any question comes corresponding to these formulas, then you will be able to answer it easily. I hope this question is clear.
Yes, sir.
Yeah, Devendra, it is fine now.
Yes, sir. Fine.
Okay. So now we will move on to the next question, which will be again formula based. I guess this formula you may know, many of you may know. So I will give you 2 minutes to solve this. If you have studied rolling, then this formula is given in every book. If you refer Dieter, then also it will be available, this formula. It's simple one. Try to solve this in 1-2 minutes, then we will go through. Could you get the answer for this question?
Sir, we have to use the formula H max equal to mu square R, sir.
Exactly. So what will be the answer?
Sir, I'm getting 2.
Okay. Devendra, you tried it?
Yes, sir.
What is the answer?
Maybe option C.
Okay, okay. Okay, sure. I will go through the solution now. Most you are correct only, like option C is correct answer, but we will go through the solution. So this is question number 45, GATE Metallurgical Engineering 2010 question paper. The maximum possible reduction in a single pass for cold rolling of a 200 mm slab is option A is 5 mm, option B is 3 mm, option C is 2 mm, and option D is 1 mm. We have given the following things like the coefficient of friction between the roller as well as between the roller and the sample is 0.1, and roller diameter is given as 400 mm. So I will draw one schematic here. Let's say a metal slab is passing through this. So this is basically, let's say we have given 200 mm. So in one pass we have certain criteria, right? So in one pass we can only reduce it to a certain point. We cannot reduce it like from 200 mm to 100 mm. So there is one criteria which tells that in one pass, depending on the friction and the diameter of this roller, so let's say this is D, and the friction between the specimen and the roller is mu. So there is one criteria which tells that the maximum reduction of the slab H max will be given by mu square R basically. So mu is the coefficient of friction between the roller and the sample, and R is the radius of the roller. So we have given mu equal to 0.1 and diameter of roller equal to 400 mm. So radius of roller will be 200 mm. Now substituting these values in this equation, so mu square will be 0.1 square and R will be 200 mm. So this will be 0.01 into 200, which will be equal to 2 mm. This is the correct answer. So the correct answer is option C. So one thing you should remember in this question is like, let's say this value which they have given is a redundant value. In equation it is not like the thickness of the slab, or let's say a sheet, is not required here. So few things in particular questions will be like that, like you will be given a certain values, but that certain values won't be required to solve the question. That you need to remember. And one main thing is like, this 200 mm will be cut short to 198 mm in one pass, because this is the maximum reduction in a single pass. So let's say I am having 100 mm sheet, still it will be 98. So irrespective of the like the sheet thickness or the slab thickness, the thickness reduction in per pass will be the same, which will be 2 mm for these given conditions. Mu equal to 0.1 and diameter of the roller equal to this. I hope this is clear.
Sir,
Yes,
clear.
sir.
Yeah, okay. So most of the times this formula will be asked. So this question comes many times. So jot down this formula somewhere. Okay, so now I will go to next question, which will be again a numerical. It is like two questions are there in that. So this is the question. So try to solve question 50 first. Here the dimensions of aluminum alloy rod is given, and you need to find, and the load, tensile load is given along its axis, and modulus and Poisson ratio is given. You need to find out when this load is applied for that cross section area and length, what will be the reduction in diameter on the applicable tensile load, on the application of tensile load. You try to solve it, then we will go through the solution. Basic stress strain equations you have to apply here. Are you trying to solve the question?
So not getting any idea, sir.
Okay, so one hint is like when you are loading, you know the load, you know the area, right? So you calculate the stress there. Okay, first thing is that. Second thing is you calculate the strain. Sigma is equal to F by A, and epsilon is basically sigma by E, which is basically the Hooke's law. So you will get sigma, you will get epsilon, and you have to relate that epsilon with other epsilon, which is reduction in diameter. I will give you one more minute. If not, then I will start with solution. Did you get the stress and strain value?
Stress I got 38.88, sir.
Okay. Strain?
Strain I didn't get, sir.
Okay. Do you want more time or shall I start with the solution?
Start, sir.
Okay. Devendra, are you trying or shall I start?
Sir, I think you try
Sorry, I couldn't get you.
कर रहा हूँ.
Okay, try कर रहे हो. One more minute then. Here you need to see which strain component you need to find, because it is asked that the reduction in diameter. So firstly, the strain which you will calculate will be in the direction of load. Right, and that strain you will have to relate with the another strain. Okay, then I will start now with the solution. So this is question number 50 and 51, GATE Metallurgical Engineering 2010 question paper. And an aluminium rod of diameter 15 mm and length 120 mm is subjected to a tensile load of 35 kN along its axis. The Young's modulus and Poisson's ratio of aluminium are 70 GPa and 0.33 respectively. The reduction in diameter on the application of tensile load is option A is 0.011 mm, option B is 0.014 mm, option C is 0.18 mm, and option D is 0.021 mm. So let's consider that we have a cylindrical rod. I'm sorry, I'm bad at drawing, but okay, let's consider this as a cylindrical rod, where what we have given is basically the length of the rod is 120 mm and the diameter is 15 mm. So, and tensile load is applied, which is 35 kilonewton. Okay, so when you apply tensile load to this cylinder, the cylinder will extend in this direction, right? So it will create a strain, let's say this as x direction. So load is applied in x direction and the strain is there in x direction. So this will be a normal strain. Similarly, because of that, there will be contraction in this direction. So let's say this is epsilon yy. Okay, so one strain is in the tensile axis direction, one strain is in perpendicular direction. So, and these two are related with each other by this formula, like sigma yy will be given by minus mu of sigma xx. So let's call this as equation 1. Okay, now we know the load, we know the cross section area. Let's calculate the stress. So the stress will be given by force per unit area. We know the force is 35,000. Okay, and we know the area will be given by pi d square. D is 15 mm. So 15 square by 4. So this will come out to be 35,000 into 4 divided by pi into 225. So let me calculate this. 35,000 into 4 divided by pi into 225. So this comes out to be 198 MPa. Okay, so mark this as equation 2. So we have calculated the stress, which is 198 MPa because of 35 kilonewton load. Now we will calculate strain. Calculation of strain. So this will be given by, let's say, Hooke's law is E is equal to sigma by epsilon. So epsilon will be sigma by E, right? So we know that stress is 198 into 10 power 6 divided by modulus we have given 70 GPa. So I am converting everything in pascals. That's why this is 198 into 10 power 6 pascals and modulus will be 70 into 10 power 9 pascal. So if you calculate this, 198 divided by 70 is 2.82 into 10 power minus 3. So this will be the strain. So I will write it here, 2.82 into 10 power minus 3. So this is 3, and this strain we have calculated, which is basically epsilon xx. Now we have epsilon xs, we know the value of mu, we can calculate this, which is, so epsilon yy will be minus of mu value is 0.33. So we will take 0.33 into 2.82 into 10 power minus 3. So let me calculate this. 0.33 into 2.82, which is 0.93 into 10 power minus 3. So term this as equation number 4. Now what is this strain? This strain is basically change in diameter by original diameter, right? This is basically change in diameter by original diameter. So
Yes, sir.
we have to calculate the reduction in diameter, basically delta D with respect to D. Now we know the initial diameter here. We know epsilon yy. We can calculate delta D. Delta D will be to epsilon yy into D naught. I will call this as D naught. So which is equal to 0.93 into 10 power minus 3 into D naught. D naught is 15 mm. So this value will come out to be 0.014 mm. So the correct answer for question number 50 is B. Got this? Both of you?
Yes, sir.
Yeah. So here two things are important. One thing is relating this the strain which is in tensile direction to the strain which will be on perpendicular to that direction, which will be negative of this. Remember, so when extension is happening, there will be contraction in another direction. So this strain first you have to calculate it from this stress. So firstly, how we went with this question? First we calculated the stress because we knew the load as well as the cross sectional area. We calculated stress. Then we calculated the strain in the tensile direction because we knew that the modulus is there. Using Hooke's law we calculated the strain. Then with the help of this strain we calculated the perpendicular strain, which is in compressive direction, basically sigma yy, and with sigma yy we calculated delta D. So this was the steps which we followed here, and for these steps the fundamental equations were first sigma, second Hooke's law, so that we get strain, and third one is this one. So these three equations we followed, and this fourth equation to calculate the change in diameter. So these were the four equations that we followed. Now you know everything here. You know stress, you know strain. Now calculate the elastic stress strain energy if you know that formula. I will give you 1 minute to solve that. Try to solve. What is the equation for elastic stress strain energy? Anyone?
So can you please explain?
Elastic strain energy. If you have studied solid mechanics, then this is the basic equation of elastic strain energy. So let me write here. So this was question number 50. Now we will solve question number 51. So the formula for elastic strain energy is basically U, which is denoted as elastic strain energy, is half of sigma into epsilon. This is the basic formula of strain energy density. So what we have to find is sigma and epsilon. So in previous question we calculated sigma, which is 198 MPa, and we calculated sigma xx also, which is basically 2.82 into 10 to the power minus 3. Now we will put this both values in this equation, which will be 1 by 2 into 10 to the power 6, means like in pascals I am doing. So 198 into strain, which is 2.82 into 10 to the power minus 3. So this overall is sigma and this overall is strain. Now if you calculate 198 into 2.82 divided by 2, so it will be around 280 into 10 to the power
Yes, sir.
3 joule per meter cube. So which will be 280 kilojoule per meter cube. So always remember, when you apply this formula, this is the form of strain energy density per unit volume, and the unit of strain energy density per unit volume will be joule per meter cube. So this is the basic formula. We derived sigma and we derived epsilon in the first question only. Just we had to put these values in this to get the second. So the correct answer for 51 is option C. I hope this formula is clear. Like, you have to remember just these basic formulas.
Yes, sir. Clear, sir. Now.
So this is the formula for strain energy density. Okay. And this is given by, basically, if this is the tensile curve, so the area under the Hooke's law, basically, this is a triangle, right? If this is the triangle, so this is sigma, this is epsilon. So the area under this curve will be a triangle, which will be half of epsilon into sigma. This is basically the strain energy density per unit volume. That's all. Any doubt in this question anywhere?
Clear, sir.
No, sir.
Okay, clear now. Okay, so that's all for today. I took 4 questions of basic mechanical metallurgy. Simple formula based questions were there. So I have like marked in every slide, I have marked this, which are the important formula. You just jot down it somewhere else so that you can revise these formulas. These questions are basically formula based. You just have to put values in the formula and you will get the answer. That's all. Is this fine?
Yes, sir.
Okay, so in next class we will deal with 4 more questions regarding mechanical metallurgy, or let's say physical metallurgy. So we will do that in next class. If you have any doubt in for this class, you just ask me. We will discuss that. Otherwise, we will close this session. Any doubt, both of you?
No, sir. Clear, sir.
Okay, okay. Then we will meet in next class where we will again go for 4 different questions. From same paper, like GATE 2010 metallurgical engineering paper. Okay.
Okay, sir.
Okay, then we will close this session. Okay, bye.
Thank you, sir.
See you. Yeah.